Hello team and welcome back to the channel. So in today's video we are going to do a practical implementation of Kafka and we are going to understand deep dive what exactly is Kafka, why do we need it and how it's going to be beneficial for us with respect to our project. So make sure to watch the whole video so that you don't miss out any of the things. Also guys, the documentation that we will be using today will be available in my Telegram server. Link will be in the description, so make sure to check it out. Now with that being said, let's get started. So team, before we get started, just to let you know, batch 12 of DevSecOps and Cloud DevOps has been started, and this is a pre-recorded batch which has 130 plus hours of content with 45 plus projects. That means it has more than 45 projects. Out of those projects, you can easily add in your resume many projects after implementation and after my discussion. Best part about this course is that you'll be having a dedicated Discord server for doubt support, so that if you are getting an issue and if you have any query, you can put it there. Plus, if you want resume review immediately, you can reach out to me. I can connect one-to-one with you, explain you what kind of things you should add in your resume and how to explain yourself in interviews. Also, once your interview gets scheduled, you can connect one-to-one with me where I can explain you, if you are in a different domain or if you are in the same domain, how to explain your projects, how to explain yourself, and how to answer questions in the interviews. So make sure to check it out. As of now, again, and also another good thing that we have decided to do with this batch is that for coming next year we'll be continuously adding more and more projects and more content in this batch. Okay, so make sure to check out all the details in the description. You can check out the syllabus, and yeah, if interested you can enroll. Now we can proceed. Hello team, so today we'll be deep diving Kafka. So here is the list of things that we'll be doing today. First, we are going to understand what exactly is Kafka. Then we are going to understand why does it exist, because I have told you before also that in DevOps, any tool that exists, it exists because it is solving a problem, right? So we'll understand why does it exist and what problem does it solve, right? That means what kind of problems we used to face before Kafka existed. Then we are going to see the working of Kafka with an example. For example, like basically how exactly Kafka works, okay, so that it becomes more clear to us like why do we need Kafka. Then we will understand the core components of Kafka with proper examples, and finally we are going to perform a practical implementation so that we can see with help of a demo that how exactly Kafka works. Okay, so all these things we are going to cover, so make sure to watch the video till end so that you don't miss out any of these steps or you don't miss out any of the concepts within Kafka. So team, now let us first of all understand how the different services communicated when Kafka was not present. So let us assume that you are working with an application that has multiple microservices. Let's say you are working with a e-commerce application, means like Flipkart, Amazon. So these kind of application will have multiple microservices like order service, then payment service, then notification service, right? Different kind of services will be there, or like analytics service. So many different kind of services will be there. So if one service need to communicate with other service, how exactly they are going to communicate? So they are going to communicate in such a way. Order, there will be, if they are deployed inside a Kubernetes cluster, they might communicate using HTTP call and like this, right? But let us understand a scenario where order has been created, like means when we try to place an order, so order got created, order ID got created, and after some time immediately like this order service is down. So if this order service is down, then payment service may not get to know that order ID has been created and I need to proceed with like taking the payment, right? So this will be a problem, because now here what is happening, these services that you see, these microservices, they are tightly coupled. Now what exactly do I mean when I say they are tightly coupled? This basically means they cannot work interdependent, like they cannot work independently. They are interdependent, they are dependent on each other for getting some information, then only they can proceed. This is what tightly coupled, they cannot work independently, right? So this is the main problem that existed before Kafka. Any of the service need to communicate with each other, they need to send HTTP call to them, right? And for some reason, if like let's say from which service they want to get some information, if that service is down, then they like the process cannot continue, right? So let us understand like how exactly Kafka can solve this problem. Okay, now see, in this scenario where I explain this communication among microservices, what other problems could be there? First problem could be there if let's say service A and service B need to communicate, but let's say if service A is down, then it's going to be a problem for service B because it cannot get information what has happened, right? Secondly, let us say that if service A needs to connect to service B, service C, service D, same data needs to be given to all these, right? And all these needs to connect to like send HTTP call to service A, right? In that case also, if service A is down, that is also going to be huge problem. That means ki data need to be stored somewhere so that same data can be stored, can be accessed by others as well, right? Third, again, what if we have a requirement to replay data? We want to use the same exact format of the data and same data somewhere else also, right? So these are the problem statement. Now let us understand how does Kafka solves this problem. Okay, so let us say we have order service, we have payment service, let's say we have notification service, we have email service. Many other service will also be there, but let us just assume with this. So now these services are there, 1 2 3 4. Now communication among themselves, if payment service need to connect to order service and get information if order is created or not, it's not going to go here. Instead there will be a separate system which is Kafka. Now Kafka will be connected to each of the service. So here what is going to happen, as soon as order is created, it's going to send a message to Kafka. What message will be there? It will be message like order created, order ID is 2. Now if payment service need to get information if order is created or not, immediately they can go to Kafka and get the information from there. So benefit that you will be getting here is that key orders, even if this service is down, still as soon as like order was created, immediately that information was uploaded to Kafka. That means now payment service is not not dependent on order service to get the information, because as soon as anything is done by order, it will be updated in Kafka and payment service can pick it up from there. Similarly, like if email notification needs to be sent or email needs to be sent, so instead of going to payment checking if payment has been confirmed or not, email service or notification service can go to Kafka and from there they can see that here information is there, order 2 is completed. So you can see now Kafka is acting like a central nervous system which is connected to each of the microservices in our project. And now any microservice who wants to communicate with any other microservice, instead of going to that, they can go to Kafka, right? That is how Kafka is solving a problem, and I hope this is clear, right? But will understand more with the proper examples, right? So in short, first the basic definition that you'll be able to see on Google or anywhere else is, it says that Kafka is open source distributed event streaming platform. But to be frank guys, this definition, even though it is correct, it's not wrong, it's correct, but to me it does not make sense. Like it does not help me to understand what exactly is Kafka. For me, better definition that I think Kafka is, we can say it's what? It's a buffer plus communication hub. Now, how exactly it is buffer and how exactly it's a communication hub? Buffer means what? Buffer means it's a log queue. You can understand buffer, you can refer to is like some kind of storage, where Kafka is storing all the different messages received by other services inside it, which is available for others. Communication hub, we just saw that it helps other services to different services to communicate with each other. Whatever information is required by others can be provided by Kafka. So for me, buffer plus communication hub, in this way I can define Kafka. But yeah, official definition is this: Kafka is open source distributed event streaming platform. But to me, this definition makes much more sense. Okay, now So next thing what we are going to see, now we are going to see the core components in Kafka. Because see, I told you ki like orders will send some data here, payment will receive it, but here in terms of Kafka there is a separate term for each thing. Like we have to understand the events, we have to understand producer, we have to understand consumer, we have to understand topics. So these are, you know, this whole process has so many different terms within it that we need to understand for understanding the proper flow. Okay, so team, now let us understand the core components. What are the core components in Kafka? Okay, first we have event or message. Now from the name itself you can understand this is the main thing, this is the actual message that is going to be stored within Kafka, right? The format will be something like this: event, and it will be like, let's say some order got created, so it will be order created, right? Then order ID. So we are specifically talking about an e-commerce application, that's why I'm using this. Order ID is 101. Then amount, it will be, let's say something, right? And then some user will be there. So in this format event will be there or message will be there, and this is the main thing that is going to be stored inside Kafka. This is the format. In this format it's going to be stored inside Kafka so that other services can get it. So event is going to be the message that is going to be stored by some service inside Kafka. Okay, second thing we have producer. Now again, from the name itself you can understand producer is like basically any service or the system who is going to write the messages to Kafka. For example, any service like order service has created this message, so that order service becomes the producer, because that is the service that is producing the event or message for Kafka, right? So it's that. Then we have topic. Topic is what? It's like a folder or category of events, because let's say ki order service is creating orders. So now orders will become what? It's a topic, or it's basically like a category. So now next next orders are coming, order ID 1, 2, 3, all those will be stored inside order topic. Similarly, let's say ki payment category is created, or payment folder you can say created. So now whatever things are coming from payment, ki this payment has been done for this user, like that, all this will be stored in this category. So topic is what? It refers to category. Okay, and here producers write to topic and consumers read from topic. Remember that. So topic is what? It basically a folder or categorization inside which any service can put their messages. Okay, now next thing we have, which is known as partition. So what exactly is partition? Now I told you that a topic is what? Topic is basically categorization. You can say a folder. Okay, so now let's say we have folder like this, order. Now this folder can have multiple partitions, like it can have order 0, it can have order 1, it can have order 3. Now what exactly these are? So basically this is the main category, order. So order related messages will be inside it. Inside this also we created multiple partitions. These are actually same things, means ki different data will be stored. Let's say ki order ID 1 is stored here, 2 is stored here, 3 is stored here, order ID 4 is stored here, 5 stored here, 6 stored here, and then order ID related information 7, 8, 9 stored here. So you can understand ki these three partitions, they are storing the same kind of things, order IDs only, right? Or order ID and related information. But you might think, Aditya, why we are keeping separately? Why we are setting up the partitions? Why? Because this will make Kafka easier to handle more traffic by parallel processing, because processing here can happen parallelly, here also can happen, and parallelly here also it can happen. Understand in like this way, ki in one go it can handle 3, right? Like that. it's not the accurate, but just for understand for parallel processing, if we have multiple partitions, then parallel processing which becomes very much easier, and this is very useful for handling more traffic. Okay, so partition is basically further creating partitions inside the topic. Topic is what? This category. Okay, similarly inside payment topic also we can have payment. Inside that also like P0, P1, P2, we can have partitions. Okay, so that it becomes easier for it becomes much easier for this parallel processing. Okay, coming to next core component, we have something which is known as offset. Okay, what exactly is offset? So now offset is the unique sequential ID for messages. For example, let's say we have order, which is the topic. Inside this we have two partitions. Let's say first partition is order 0, second partition is order 1. Inside order 0, let's say we have written like order IDs. Let's say the first is order ID 101, then order ID 102, and inside these order IDs other information is there, but this is what? This is a unique sequential ID. Okay, this is how you'll be able to identify the order ID 101. We can pick it up and we can find other information. So this is like a unique ID, you can say. Okay, so this is what? This is offset. This is how storing will be done. Okay, next thing what we have, consumer, which already you can understand key the service that is going to read from the Kafka, not put messages inside it, but read from Kafka. Okay, for example, let us say this is our Kafka, and here we have, let's say, order service, and here we have payment service. So order service is, as of now, it's what? It's producer, because it is creating event or messages and putting it to Kafka, while payment service is reading from it. Okay, or getting it. So payment service will become the consumer. Okay, next core component that we should know about is known as broker and cluster. Now you can understand that if you are setting up Kafka server, then if you are having just one Kafka server, it won't be enough to manage a huge microservice based application. Okay, so in that reference, try to understand. So if you have set up one Kafka server, that single Kafka server is known as broker. If we have multiple brokers, means multiple Kafka servers, then you will call them as cluster. Okay, so understand that. So in total, what we understand about core components, first we understood about the events or messages. Second, we understood about the producers who is going to create the messages or events opposite to Kafka. Third, we understood about topic. Topic is what? Is basically a categorization of what kind of messages we are having. Fourth, we understood about partition. So inside a topic we can have multiple partitions, so that parallel processing is much easier. Then we understood about offset. Offset is what? Whatever like events or messages are being put, so they will have a unique sequential ID. That sequential unique ID is offset. Then we understood about consumer. Consumer is what? Consumer is basically the one that service that is going to read from Kafka. And then we understood about broker and cluster. Okay, so these are the core components when we talk about Kafka. Now let us move to practical demonstration, like we are going to implement Kafka, and let us see how exactly it's going to work. So Tim, now let us get started with the demo. So first of all, we are going to set up a demo, set up Kafka servers using Docker Compose. So for that, I'll create a machine. Okay, before creating the machine, do one thing. Make sure you have certain ports open. So for that, we'll go to security group, and I'll go to this primary SG. Here I'm going to modify a few things. Here I will add range 2000 till 10,000, because most of the things I do will exist in this range only. So I'll open this range, I'll save it, and then I will I'll create the EC2 machine of Ubuntu type version 24.04 LTS. Size will be T2 medium, because again it's more than enough for us to set up a demo. Keep here we can select the one that we have on our local machine, and security group. Storage I'm going to be giving it at 25, which is again enough. So machine has been created. Now let us connect to it. So I'll copy the public IP, go to 𝗪𝗶𝘁'𝗀 and let us run it inside 𝗪𝗶𝘁'𝗀. So I'll just rename it, change the public IP, because username is same and as such private key is also same. So I can just change the server and it should be fine. Let's double click on it. Now, so machine has been created. Now let us install Docker and Docker Compose. So first of all, we are going to run sudo apt update. After that, we'll go on browser, and on Google we have to search for Docker install, and it will take you to this page where on left side you can see installation option is there based on what kind of machine you are having. So currently I'm having Ubuntu, so I'll scroll down, get the command to set up the Docker apt repository, and then run the command to install Docker latest version. Okay, now let's wait for this to complete. Meanwhile this is happening, you'll go back to this page, scroll down where you see Docker Compose, and click on this option which says install. Click on this standalone, and now these two commands we have to run in order to install Docker Compose. Okay, so this is done, Docker is installed. Now what we have to do, we have to make sure that Ubuntu user has permissions to run Docker commands. So we will run sudo, we will add Ubuntu user to Docker group, sudo user mod -a capital G Docker, which is the group name, and Ubuntu, which is the user. And for these changes to take place immediately, you can run new group Docker. So now this is done, and we are going to install Compose. So we are going to run the command using sudo. And the copied command. So now Docker and Docker Compose, both of them are present on my machine, and Ubuntu user has permissions to run it. Now what we are going to do, we are going to set up Kafka. Okay, now note that one more thing, while setting up Kafka you'll be needing few more things. Okay, so let me explain you what other things you are going to be needing. First of all, let us create one directory. Let's call it as Kafka demo. Okay, and we will go inside the project. Now I'm going to create a Docker Compose file, docker-compose.yaml. So now we have to write the Docker Compose file. Now let me explain you what things I have added in this Docker Compose. First of all, I'm adding 𝗪𝗍𝗑eeper. Now what exactly is 𝗪𝗍𝗑eeper, and why did not I used it or explained it previously? Because in the upcoming versions or the latest version of Kafka, 𝗪𝗍𝗑eeper is not mandatory or not required. But in older version or the current companies that are using, they might be using 𝗪𝗍𝗑eeper. What exactly is 𝗪𝗍𝗑eeper? So it's a service that is going to store metadata of Kafka. Like Kafka means ki you mean I told you ki a server is broker, like Kafka server is broker. So how many brokers are there, what will be their ID, all those information plus like other information, everything, all the metadata will be stored inside 𝗪𝗍𝗑eeper. So we are setting up a 𝗪𝗍𝗑eeper. For that we are defining the name 𝗪𝗍𝗑eeper as a service. Image we are using this one, container name will be 𝗪𝗍𝗑eeper, and two environments we are defining. First, client port. This is the port on which Kafka can connect to 𝗪𝗍𝗑eeper. Then we have tick time. It's basically the unit that 𝗪𝗍𝗑eeper is going to be using, 2000, which means 2 seconds. Then we have port mapping. So 𝗪𝗍𝗑eeper will be running on this. Then we define Kafka. Image will be this one we are using. So set up Kafka. Container name will be this, and depends on 𝗪𝗍𝗑eeper because we want that after 𝗪𝗍𝗑eeper has been created, then only Kafka container should be created. Next thing we are defining environment. So here first thing we are defining Kafka broker ID. Broker ID, I told you broker is what? It's single Kafka server. So here we are setting up one server only. That's why we have written broker ID 1. Kafka 𝗪𝗍𝗪𝗀 connect. So here we are defining ki to 𝗪𝗍𝗪𝗀 how Kafka can connect, which is service name and then the port, right? Then we are defining Kafka listener. So basically here defining that Kafka is going to listen on this port, this IPN port inside the container. This means ki any IP. Then we are defining Kafka advertised listeners, which basically means ki this Kafka broker will be reachable by other things on this, okay, on this port and with this name, service name. Then we are defining Kafka offset topic replication factor. In simple, we have set it to 1. In simple factor, try to understand that how many brokers you are having, that number you are going to put. For example, let us say that we have 2 brokers. We are going to put 2 here. What exactly by that we mean? It means that let us say we are storing data on one of the broker, on one of the Kafka server, and the backup will be stored on second. So here we are having just one Kafka server. That's why I have written 1. Then port information, this is the port on which Kafka will be running. Then now the thing is ki I want that I should be able to access Kafka server over UI as well. By default we did not set up, but later on I added Kafka UI also. I am adding it so that we can see Kafka over UI also in browser, so that it is easier for us to understand different things. Here we are defining container name as this, and this is the image we are using. And depends on this. This means ki Kafka and 𝗪𝗍𝗪𝗀 are created, then only Kafka UI container will be created. Port information is this, so that will be able to access Kafka UI over browser on this port. Environment we are defining first Kafka clusters name local, because we are setting up a local cluster. Then Kafka will be accessible here and 𝗪𝗍𝗪𝗀 will be here. So this is what you have to use. Now we will save this and we can run it. So I can run the command docker dash compose up, okay, and -d so that it runs in background. So we'll wait for it to complete. Now these 3 containers will be created. So let's see how it goes. Since we are doing this for the first time, that's why it's taking a little bit more time to download the images and create the container out of it. So here we can see all the 3 containers are created. We can verify by running the command docker ps. We can see all 3 containers are running. So now we can access Kafka UI over browser with the IP where we have just set it up. So we can go on browser, and as you remember, the UI part was running on port 8080. Now this is the first thing that you are going to see when you set up your Kafka local server, okay. And now let us explore the topics and let us set up a demo so that we can understand in little bit more detail how exactly it's going to work, and also we are going to see if it is working well or not. Okay, so this is the UI, and here the information about your server. In broker section, if you have multiples, then you will be able to see multiple Kafka servers. Here is the topics where you can create topics inside which you can like events will be put, the messages will be put, and here we have the consumers, right? So in order to set up a demo, what we are going to see, as of now there is no topics created. So first of all we are going to go to topics, click on add topic, and let us provide a topic name. So I'm going to name it as demo dash topic dash 1, okay. Number of partitions, only 1 I'm keeping, and cleanup policy we will just leave it as it is. Replication factor just 1, because again there is only one server, so we do not have any separate backup. And time to remain data I'm just keeping as 7 days, and let us create the topic. Okay, so now one topic is created. In topic section, demo topic is created, and as of now there are no messages here, right? Now what we are going to do, we are going to produce and consume messages, or basically produce and consume events, okay. For that, what we can do, we are already inside the demo topic 1, okay. So here we will click on produce message, okay, and here 2 sections where you can see, one is key, one is value. So here it's kind of an optional thing. Still, you can just put like this, order -1, and in value you have to provide some kind of information like order ID, status, like that. For example, I can put the status as this one. Okay, order ID 1, status created. Right, now we will click on produce message. So message has been created, right? So basically, once you have created the message and once you refresh the page, in messages section you will be able to see your message, the one that you just created. Okay, so here what exactly happening here? The Kafka UI, this separate server we have, this UI part, this is considered as a separate service. So here, using Kafka UI as a producer, we created the message, and Kafka UI, which is also the consumer of the message, is able to view the message. That's why here you will be able to see one message consume. Okay, let us see with another example. Let's say here I am creating another message, order 2, and here we can provide the proper formatted value. Let's say this is order number 2. Now I click on produce message. So message has been successfully sent, right? But as of now it's not appearing here, right? As soon as I refresh the page, go back here and go to messages, you'll be able to see order has been created. Second order that I just created previously, a little bit like a while ago. That's why 2 times it's showing. So basically it shows that Kafka UI, which is also our producer in this case, and Kafka UI, which is also the consumer, both the things are working fine. That means ki Kafka UI, which is another service, sending a message to Kafka, and Kafka UI separately is able to consume the message as well. So this is what just happened. We are producer, the Kafka UI was producer, created the message, it went into Kafka, got stored there, and eventually consumer, which is the Kafka UI, same thing, but it is able to consume the message created separately, and basically it is consuming the message from Kafka server. Okay, so this confirms that it is working fine. Now we are going to see the same thing via terminal, like using the CLI. So we have seen the demo properly from UI side. Now let us see using the CLI. So first of all, what we are going to do, we are going to go inside the Kafka server. So we can see these containers available. So we are going to go inside the Kafka container. For that you can run docker exec -ipd Kafka. Okay, and here we have the middle one, is the Kafka server with the name Kafka. So using this command we'll be able to go inside it. Now here you can see app user this. So this is basically now we are inside the Kafka. Okay, next thing what we are going to do, we are going to create a topic using command. So I'm going to create a topic named demo topic. Previously from UI we created a topic named demo topic -1. Here I'm going to create a topic named demo topic. Okay, again other things will be the same, partition 1, application factor 1. So let us run this. Demo topic got created, right? We can confirm by running the list command inside the same terminal. Here we can run list, and here you can see 2 topics are present. One topic which we created from UI, second topic demo topic which we created from the CLI. Okay, now what we are going to do, we are going to start a consumer. Okay, so for that also you can run the command Kafka console consumer. This command you can execute topic demo topic. Basically we are telling that there will be a consumer who is going to consume events from demo topic, from this topic, right? So we will run this as well. Okay, now we will leave it open. Now what we are going to do, we are going to open another terminal where we are going to produce the message, and then we are going to see if here it is able to consume the message or not. Okay, so now again we will open the Kafka container here in different terminals has opened. Now what we are going to, we are going to start a producer who can produce messages. Okay, now let us type hello Kafka, then we will type this is my first anything you can type, we are just doing a demo, and let's type type DevOps Shack Rocks. Now here we can go and you can see all those messages are being consumed here by the consumer as well, right? So from the UI also we can confirm that it is working fine, right? So basically the whole point that I was trying to explain is that Kafka is something which acts as like a nervous system, and now multiple services, if they want to communicate with each other, they can easily communicate by putting their basically sending their events or messages inside Kafka, and other services can pick it up from Kafka itself. Okay, so thanks for watching guys, and have a nice day.